Okay, actually, we are going to study the how to derive the formula for radius of curvature. Okay, of a complete derivation. How can we find out the radius of curvature? The radius of curvature is the radius of the osculating circle, which approximately best approximate of that curvature, that part of the whatever this curve at that particular point. Okay. Now, suppose we have a curve here and there is a point P and Q. Actually, what we want curvature first. Means, what is the change in the tangential direction for just at that particular point P? Means we want to calculate, first we have to calculate what is the change in the tangential direction as a P is very close to the Q, and if you divide by that small minute change distance from P to Q, you can get it. That actually we want it, and if you make a reciprocal of it, that we can get it, whatever the thing we want, radius of curvature, because that is we can get radius of curvature. For that, I want at that particular point what we know, we have a tangent here, okay, which makes an angle psi with axis. That information I know, okay. And is y is equal to f of x is given the curve. Just we know that the slope of the tangent at that particular point is equal to, sorry, the slope of the curve at that point is equal to slope of tangent at that point. That is equal to dy by dx. With this information, I know I need to, means I need to find out d phi by ds. How can we get going to find out d phi by ds? That's we are not d phi by ds, d psi by, there is psi here, that is psi, the tangent that we are going to make psi with the x-axis here. That's we want actually d psi by ds. Okay, for that only information we know that it makes an angle psi with the x axis at that based on that we can find out the d phi dy by dx is equal to tan psi. And if you differentiate it with respect to x again, since what you can say that d square by dx is equal to second square psi with and d psi by dx. Okay, that is second square psi with d psi by dx here. Again, we are going to use a chain rule here. What is the chain rule we are using here? That is d d phi by d psi by dx is equal to d by. See here, what we will going to, this can be replaced by this one, because we can rewrite like this: d psi by dx is equal to d psi by ds into ds by dx. Okay, no problem, you can get same thing. Okay, why? Because keep in mind chain rule, why we are applying here. Whatever the, I can say that the psi is function of distance traveled, as is a function of, I can say that distance along the curve. Again, distance along the curve is a function of x here. Therefore, we can use the chain rule here: d psi by dx is equal to d psi by ds into ds by dx. Okay, that's why we are using the chain rule here. Then if you substitute back into this equation, we have d square y by dx is equal to second square psi into d psi by ds into ds by dx. Okay, we already know that we actually here what we require this, we already know that the curvature is always at a point here. Whenever we are calculating the tangent at that point, we are going to this one d psi by ds is curvature at that particular point, you can get it. Therefore we can say that this is what we want. Actually d psi by ds is called, this is 1 upon 2, it is a reciprocal of radius of oscillating circle. Now this is what actually the second square can be written as 1 upon tan square psi. This is 1 upon dy by dx whole square. Okay, and already what is ds by dx we want? Actually we know that ds is equal to this whatever this, I can say that whenever q tends to p, this ds becomes act as a hypotenuse. Okay, act as hypotenuse, and this is what dy and this is dx. That is what we can say that by arc length formula, can ds by dx is equal to square root of. See, because once it is act as a hypotenuse, that is Pythagoras theorem, we can ds square is equal to dx square plus dy square, and we can get ds by dx whole square is equal to 1 upon 1 plus dy by dx whole square. This can be written as ds by dx is equal to square root of 1 plus dy by dx whole square. Therefore, we can get it. Now, after substitution back into the equation, we can get ds square y by dx square is equal to just we can make a substitution, and those things. You finally, after simplification, you can get one the row. The radius of curvature is 1 upon dy by dx whole square raised to 3 by 2 divided by d square y by dx square. This is what actually, see here, what we are doing here means there is a curve is given, and one only the point is given p of x1 y1. Okay, let us me call this, that is curve is given at x comma y. Any point you can say that x comma y. With the point and the equation of the curve, we can find out easily. Note what actually, see here, whenever in the problem they given curve equation of the curve at any point on that, and we can easily find out dy by dx at that particular point. That is equal to that is equal to, I can say that slope of the tangent at that point, the slope of the tangent at that point. Okay, the same, that is tan phi. Now if we differentiate it, what we can get d phi by ds, that is nothing but the radius of curvature. Already we explained earlier, that is we find out. Based on that, we can, if you differentiate with respect to again x, we can get d phi by ds in the in that, but by using, with these two given information, we can easily find out d phi by ds. The rate of change of this amount of change in the tangential direction with respect to change in per unit change in the distance traveled along the curve. That is what, that is how we can define, we can derive the formula here. But the only thing, if they given in the problem itself, if they ask to find out radius of curvature, if they given curve and equation of the curve and point is given, just you have to find out dy by dx, and then it is you can apply. And only if you know that, that is only enough, is I enough is is that you should know the equation of the function in the form of y squared f of x, and we know also, we also know the point, because at what point we need to find out the radius of curvature. At that particular point, if I want to find out, this is the general formula, I can get it. Okay, thank you very much.